This is Unit 2H, which deals with space and the universe and the evolution of stars in particular. So on this first graphic here we have a number of different scales of evolution. We're most familiar with biological evolution, but really that's just one of many phases of evolution. We have the idea of the Big Bang right here, and in the very early stages we get particles being formed and developing. Then we get galaxies clustering, coming together, being born. Stellar evolution, we get different generations of stars and they create the heavier elements. Those heavier elements are dense enough to form planets, so we have planetary evolution. We then have chemical evolution when we have the right amount of energy and we have fluids on some of those planets. We then have biological evolution as molecules begin to make copies of themselves. And eventually we have cultural evolution, certainly humans, but some animals do have culture as well. So we have a grand scheme here, and it's the stellar evolution that we're most interested in this particular case. So let's have a look. We start off with something called a stellar nebula, which is just a grandiose term really for a big cloud of gas. Gravity draws this in. Now, depending on the size of the gas, cloud of gas, two things happen. An average sized star will burn for a few billion years. Eventually the expansive forces will win and we get a red giant, and that will eventually die. It will puff away its outer layers and we're left with a white dwarf. A more massive star will have a different evolutionary path. In many ways it will be similar to begin with, but it could become, or will become, a red giant, so the same idea but much bigger. Now again, depending on the size, it could go supernova, which is a spectacular explosion when the expansive forces win. So for a few months, the term supernova means, well, nova means new, so a new star that we see, because normally it's not bright enough. And again, depending on the size of it, two things can happen. It can turn into a neutron star, an incredibly dense star which may rotate, or it can become a black hole, which is a collapsed star that's so dense, has so much mass that even light can't escape from it. Now we have this diagram here that is fairly complicated but sort of tries to summarize what's going on. We have this is called the main sequence, so if I move the laser pointer through the time, we get very hot blue stars here to begin with. They do mellow a bit, they get redder as they get older, but then they jump to here, they become giants or supergiants as we've seen, and eventually they jump to this section of the diagram where they are effectively at the end of their lives. So we have this metaphor of stars being born when they're created and dying, which is a very useful metaphor, even though it plays out over billions of years, but it's a way of describing how they change and evolve over time.